Okay, let's look at Pezzoli number 2. So this is the winter 18 midterm Pezzoli number 2. We have a cone that's got water partially filling it, and they say that the water is leaking out at 2 cubic feet per hour. So we'll call that V dot. I notice they don't use the dot terminology. Not everybody does. They should. It's much easier. So V dot is -2 cubic feet per hour. So right away we got to worry about units. I think they use feet everywhere, and this is the only time. So then I guess we'll have our time in hours. So yeah, so I think we're safe with units. Everything's in feet, and then time will be in hours. Okay, so then they want to know what rate is the area changing when the depth of the water is 3 feet. So when this D here is 3, how fast is the area changing? So we want area dot, and this is the area of the surface of the water. Surface of the water is pi r squared. So the area is pi r squared. We want to know how fast that area is changing. So obviously it's going to be going down because the water is leaking out at 2 cubic feet per minute. So we got to remember to make that negative. Okay, so we know V dot. We want A dot. That's how these related rate problems work, right? We know the rate of one, we relate that so we can find the rate of the other one. Okay, so let's see. First, let's do our similar triangle thing. We know that it's 5 feet. They tell us the radius of the cone is 5 feet. The full cone wide, the radius is 5, and the full height is 10. So we can do our similar triangles. The little triangle, which is actually the water one, this is 3. The depth is 3, and we don't know the radius, so that's what we got to figure out. All we know is when the depth is 3 feet, but we know the ratio of this thing is 5 to 10. The depth is always, well, okay, we can just do it this way, right? The radius 3 is to r. 3 is to r as the big side, as 10 is to 5. So the radius when the depth is 3 feet, that's what this r is. Let's see, that's 2. So 3 over r is equal to 2. Multiply r by both sides. 2r is equal to 3, or r is equal to 3 halves, or 1.5. So when the depth is 3, the radius is 1.5. Okay, so that's one thing to know. We want to know when the radius is 1.5, how fast is the area changing? Okay, so let's see. The area of a circle of the surface of the water is pi r squared. We want to know A dot. We take the derivative, right, with respect to t of both sides. Take the derivative of this whole thing. Derivative A is A dot. That's easy. Pi stays there. Derivative of r squared is 2r times r dot. Right, times the inside derivative of anything is squared is 2r times the derivative inside is r dot. So A dot is just 2r r dot. We know what r is. R is 1.5 when we want it, but we don't know what r dot is. So now we got to figure out what r dot is. We do know what V dot is, so from V dot we got to figure out what r dot is. Okay, so let's do that now. So let's figure. So the volume of a cone, like the volume of our little water-filled thing there, is 1/3 pi r squared h. Well, we don't want this h in there. We want only r's, so we got to get rid of the h, but we can do that with the similar triangles again. So we know that same thing up here. The height is 10, the full height is 10. So we want h in terms of r. So the height to r is 10 is to 5, because the full radius is 5, so it's 10 to 5. So let's see, we want h, so h is equal to 2r, which of course we knew that. The height is always twice the radius, right? The height's 10, the radius is 5. So h is 2r. So we can plug that in here. So the volume then is 1/3 pi r squared times 2r. which means our volume is 1/3, let's see, 2/3 pi r cubed. Okay, so that's the volume after we get rid of the h. It's 2/3 pi r cubed. Now we want v dot. Let me draw a line here to separate my work here. So we take the derivative with respect to time. So the derivative of v, of course, is v dot. Derivative of this, the 2/3 pi stays. The derivative of r cubed is 3r squared times r dot. Let's see, the 3's cancel. That's really nice. So v dot then is 2 pi r squared r dot, which we know is -2. So r dot now we can find, and then we can plug that back into here to find a dot. Okay, so r dot then, put everything on the other side. R dot is -2 divided by 2 pi r squared. 2's cancel, that's nice. And we want to know r dot when r is 1.5, right? When the radius is 1.5. So r is 1.5, the 2's cancel, so that's -1 over pi times 1.5 squared. And now the question is, do we keep it perfect? We might as well keep it perfect. So 1.5 squared is 2.215 times 15, 2.25. 5 squared. Yeah, 2.25. So -1 over 2.25 pi. That's, yeah, I'll write it like that. -1 over 2.25 pi. Okay, that's kind of an awkward number, but oh well. Okay, so that's what r dot is. Now we can go back up here and say, okay, this is equal to pi. We want to know a dot when times 2 when r is 1.5, so 1.5. And we know that r dot is -1 over 2.25 pi. Here's why it was nice to keep it perfect. We didn't get decimals because look, the pi's cancel. That's nice. And so that's -2 times 1.5 is -3. So that's -3 over 2.25. Let's see what that is. 3 divided by 2.25. Okay, now I can get, it looks like 1 1/3. So I get 1.33 forever. And that would be in its area, how fast the area is changing. So that would be feet squared per hour. So feet squared per hour. So that's, yeah, 1.33 feet squared per hour. They write their answer as 4/3. It's Pezzoli's 4 is really hard. It looks like it's at 9, but they say negative. Oh, and it's negative because it's getting smaller. So 1.33, 1 1/3, 4/3, and she also put second, and that was wrong because we're dealing with hours here. So hopefully that didn't confuse anyone. So she made a mistake there. I think it's a she. Okay, so that's Pezzoli number 2. Typical related rate. So hope that makes sense.